first review our rules from yesterday. Our rules from yesterday were if you have the same signs, you're adding the same signs, then your answer is that sign. If you're adding two negatives, your answer is going to be negative. But if you're adding opposite signs or different signs, then your answer is going to be the sign of the larger number. So when I say larger number, I mean if it's -5 and +1, the larger number is 5, right? Our rules for subtraction. Say you're subtracting two positives. We did what's called keep, change, change yesterday. Keep, change, change being you keep the first, change to a plus, and change the number to its opposite. That's for subtracting. The rules for multiplying and dividing are the same. Positive times a positive equals a positive. Negative times a negative also equals a positive. Negative times a positive equals negative, and positive times a negative also equals a negative. These rules are the same for division. So these sets of rules carry over with rational numbers completely. Whether you're working with integers, fractions, or decimals, these rules carry over either way. If you haven't already, you want to go to my website and you want to type in rational free as the last part. It will give you a resource opportunity to get a resource that will work with talk about all these things I've talked about here, but then put it in more of a chart form so you can do it as a one glance. It includes integers, decimals, and fractions. Okay, so let's do some adding examples for decimals. Adding example. Okay, I've got -2.34, and I'm adding that to a -1.5. Well, these are the same signs, yes. So we're adding the same signs. Our rule says that we add them and keep the sign. So we remember when you're working with decimals, you have to line up the decimal points in order to do your adding and subtracting. So we've got 2.34. We're adding that to 1.5. Notice I've got my decimals lined up. The decimal goes down into the answer. 4 and nothing equals 4. 3 and 5 is 8. 2 and 1 is 3. So because these two add-ins are negative, our answer is going to be negative. -3.84 is our answer to that one. Let's do another example. So we have -1.2 plus 3.47. Again, now let's look at the signs. This one's negative, this one's positive. Our rules say for two different signs, we subtract them and keep the sign of the larger. Two different signs means you have to subtract them and keep the sign of the larger. So we put the bigger number on top because we're going to subtract. Even though this is an addition problem, at this point we're subtracting. It's addition, but we know we have to subtract, and then we'll work on the sign at the end. So 3.47 minus 1.2, bigger number on the top. Remember, line up the decimals, put that down in your answer. 7 minus 0 is 7. 4 minus 2 is 2. 3 minus 1, also 2. Of these two numbers, 3.47 is the bigger number, so we subtract and keep the sign of the larger. So our answer is a positive 2.27. That's when we're adding. Same signs, add and keep the signs. Different signs, subtract and keep the sign of the larger. So let's move on. If we're doing some subtraction problems, let's do some subtraction examples. And my objective here is to make sure that I give you enough information to clarify some things that you may be confused about. But I want you to know that we go much more in depth in the course that I'm pre-launching. That's why we're doing these videos set to pre-launch the course on November the 1st. But we're doing these different examples, a little tips and tools, so that way we can get a good handle on some basics. 2.5 minus 6. Well, remember our rule of keep, change, change. When we're subtracting, we use keep, change, change all the time. We keep the first one. We change the minus sign to a plus. We change the 6 to its opposite. Now we have an addition problem. And we know the rules for addition say that if they're different signs, we subtract them and keep the sign of the larger number. So in this case, 6 is the bigger number. It must go on the top. So if you don't know, the decimal on the 6 is hiding here. If you don't see a decimal, then it's at the back. If it's somewhere else in the add end, then you're going to see it. If you don't see a decimal, it's at the back. Okay? And we're subtracting 2.5. Now, a common mistake that many students make is to go ahead, even though there's nothing here, they just subtract this 5. Well, you can't do that because there's an invisible 0 right here. There's an invisible 0. That's like 60 minus 25, even though we have decimals. So we bring our decimal down into the answer. Well, 0 can't take away 5. We must go over here and borrow, which makes this 10. 10 minus 5 is 5. 5 minus 2 is 3. So looking at the two add-ins, we have which one is larger. The 6 it's negative, so our answer, negative 3.5. We subtract them and keep the sign of the larger. Another example. Negative 3.15 minus 2.763. Working with decimals. Whew, we're having fun. Talking about, many times we incorporate decimals when we're talking about money. But if you go into multiple digits, you may be talking about other things. But let's follow keep, change, change. We keep our first number, change our minus sign to a plus, change our 2.763 to its opposite. Now, when we look at these two add-ins, we see that they are the same sign. So our rule says same signs add. Yeah, same signs add and keep the sign. This is the rule. This rule goes all the way through decimals, all the way through fractions, all the way through integers. That rule remains the same. So we're adding two of the same signs add. So let's put them in order here, 3.15 and 2.763. Again, notice I lined up the decimals. Bring our decimal down into our answer. Okay. We can put our 0 here. We're adding, so it's okay. Whether that is or is not there is all right. 3 and 0 is 3. 5 and 6, 11. Carry our 1. 7, 8, 9. 3 and 2 is 5. So looking up at the add-ins, both of these are negative. Same signs add and keep the sign. So our answer is negative 5.913. Okay. That was adding and subtracting that we just did. So now let's refresh our mind again on the multiplication rules. If you multiply same signs, you get positive. If you multiply times a negative, you get a negative. These same rules apply for multiplication and division. If they're different signs, the answer is always negative when you're multiplying and dividing. If they're both positive or both the same sign, the answer is positive. This is a place where many students get confused with multiplying different signs And in this case up here, where we were adding different signs and we kept the sign of the larger. Down with multiplication, it doesn't matter which one is larger. It's negative if it's one negative or three negatives or any odd number of negatives. Let's do some examples. 3.6 times negative 2. Okay, we just need to multiply right out. Doesn't matter what the signs are right now. We worry about the sign at the end. So we take our 3.6, multiply times 2. You see also no need to line up the decimals. We'll put our decimal in the answer based on the number of digits after the decimal. We don't have to line them up and do that, not for multiplication. Okay? 2 times 6 is 12, carry our 1. 3 times 2 is 6, plus 1 is 7. So, because there's one digit after the decimal in the two products, then there should be one digit after the decimal in the answer. Remember, we had a positive and a negative, so our answer, negative 7.2. Lots of things to remember. You have to remember how to multiply, remember how many digits are after the decimal, and put the decimal in the right place, and remember that two different signs gives you a negative answer. Maybe that's why students get confused. Too many things to remember. Okay, let's do another example. Negative 4.51 times negative 5.6. Two negative signs. So our answer is going to be, I'm waiting for my class to answer. Your answer is going to be positive. It's going to be positive. Thanks, Pastor. I appreciate that. Okay, so let's go. 4.51, and we're multiplying times 5.6. Again, it's not important that you line up the decimals. Not relevant. We'll worry about where the decimal goes at the end. So let's do our long multiplication. 6 times 1 is 6. 6 times 5, 30. Carry our 3. 6 times 4, 24, plus 3, 25, 26, 27, right? 27. Make sure now that you index this 0. Another common mistake, forgetting to index the 0. Now we've got 5 times 1, 5. 5 times 5, 25. We're carrying our 2. 5 times 4, 20, plus 2 is 22. We're adding these together. Start at the ones place. 6 and 0, 5, 5, 7, 5, 12. 2, 2, 4, one more 5, 2. So where does our decimal go? Our decimal goes 1, 2, 3 digits after the decimal in the products. So it should go 1, 2, 3 digits from the end. Notice I didn't go from this side going the other way. I started at the back and moved forward. So both of these are negative. According to our rules over here, negative times a negative equals, this should be an equal sign, oops, equals a positive. So our answer is positive 25.256. Wonderful, wonderful, wonderful. Okay, so now we've covered adding, we've covered subtracting, we've covered multiplication. Let's cover division. Remember, the rules for division as far as the signs go are the same as the rules for multiplication. So positive divided by positive equals a positive. Negative divided by negative also equals a positive. Positive divided by negative equals negative. And negative divided by positive equals a negative. Same rules that we had for multiplication. So now let's do division. Division. We have 10.2, and we're dividing that by negative 2. Well, 10.2 divided by negative 2, our answer is going to be, what's our answer going to be? Our answer is going to be negative. Very good, yay. Let's do our 10.2 divided by 2. In this case, when you're dividing decimals, you need to divide by a whole number. This example doesn't have a decimal in the divisor, but I want you to, we'll do an example that does have a decimal here so you'll know. You must divide by a whole number. Must divide by a whole number. So if there's a decimal in the divisor, you need to move it enough places to get a whole number and the same number of places inside to make that one a whole number. So in our case, 2 goes into 10, 5 times 2, 10. I hope you all remember how to long divide. Bring our 2 down. 2 goes into 2, 1 time, 2 times 1, 2. We subtract and we've got 0. So where does our decimal go? Well, our decimal goes right up from here into the answer. So because we have a positive and a negative, and according to our rules, the answer should be negative, we have negative 5.1 as our answer. So let's do one that has a decimal in the divisor. Negative 4.95 divided by negative 1.5. Okay? Again, we're going long division. The first number goes inside the house, as I tell my students. First number goes inside the house. Well, we need to divide by a whole number, according to this rule up here. This is not a whole number, it's a decimal, so we need to move this one place to the right in order to make it a whole number. We also need to move this one place to the right. Same number as out here. This doesn't have to be a whole number. The outside number has to be the whole number. Okay, that's another common mistake students make. Is the outside needs to be a whole number. So you move it just enough places to get it to be a whole number. You move it 1 here. You can go ahead and take the decimal up into the answer. That way you won't forget it later. Okay, so 15 goes into 49 3 times. 3 times 15, 45. Subtract here. We have 4. We bring down our 5. 15 goes into 45. Again, 3 times. 45. We're done with this one. But let's look at our sign. Negative divided by negative. So according to our rules up here, negative divided by negative is positive. So our answer is positive 3.3. If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemaths.com where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathshelp.com. We look forward to seeing you there.